Hey crew. Okay, we're in our final unit of math. Now, my plan is to get all these math lessons done this week. Probably not necessarily all of them done by tomorrow, but this week. So by Friday, you will have everything that you need. You can finish up with all of it, okay? Now, as usual, if you want to work ahead, you can if you can figure these things out. But what we're going to be covering in Unit 7 of math is a lot of stuff that's prepping us for third grade. So we're not going to cover it to the point where you're going to have this completely, totally mastered. It's just kind of an intro to what you're going to be doing in third grade. Now you're going to notice that some of this stuff is going to have to do with multiplication, which is more of a third grade skill. But we have talked about it a few times here in second grade. Some of you've worked on multiplication math facts. Some of you probably are still doing that with Mobimax. So this is going to deal with some multiplication, including what we do today. What we're going to work on today in this first lesson, which is on page number 369, is what are called arrays. Now we need to understand a few terms before we work with array, okay? Now, A-R-R-A-Y spells array. It's all one word, array, okay? This isn't like a ray gun shooting like that. It's called an array, which means it's something that's set up like this, where you have rows and you have columns. So when they ask you about rows, they're talking about things that go this direction, okay, horizontally. Columns go vertically. Now this is confusing in our classroom because we talk about rows in our classroom going this way or this way. So it's a little confusing, but when we're talking about in math or in other places, when they talk about rows, they're talking about horizontal, things that are going this direction, okay? When they talk about columns, they think about going this direction. In fact, if you think about what the White House looks like in Washington, D.C., it has pillars that go this direction along the front of it. Sometimes people call those columns. So columns go vertically, like a pillar. The rows go horizontally, like the horizon line, okay? So, number 1 on page 369 says, circle the rows. So rows go this direction. So we're going to circle the row. We're going to go, starting here, go all the way and circle it like this. And then we're going to do the same thing and circle that. So how many rows do we have there? 1, 2. 2 rows. Now number 2 says circle the columns. So we circle the columns, we're going to go this way. And there's one column. There's one column. There's a column. There's a column. And there's a column. And how many columns do we have? 1, 2, 3, 4, 5. 5 columns. 5 that are going vertically. Those are columns. Okay? So, now we can take a look at some arrays. Arrays are just like this. They have rows and they have columns. So, on number 3, there's a little dash off to the side and a little dash down below. And what they're saying is they want to know how many are in each row and how many are in each column. So in this row we have 2. In this row we also have 2, and in this row we have 2. Which makes sense, because if you are working on arrays, arrays should have the same number in every row and in the same number of every column. That's what makes them an array. Otherwise they're just a jumbled mess. Now, let's do the columns. In this column we have 1, 2. Okay, well that's a dead marker. Oh, guys, you missed it. I made that basket. It was like, oh, yeah! That was amazing. Totally missed it. Sorry. I could have turned the camera for you, but I did. See if this marker works. So we have 3. Good, this one works. And this column, we also have 3. So now that we know this, that we have 2 in each row and 3 in each column, the bottom line, it says what you're going to do is you're going to write 2 equations for each array. Now, here are the equations that we're going to do. We're going to do repeated addition equations. Wow, those are some big words. Repeated addition equations. So, we can go 2 plus 2 plus 2 And that equals, well, let's skip count. 2, 4, 6. 2 plus 2 equals 6. 2 plus 2 plus 2 equals 6. Okay, then the second equation we can do is we can add together the columns. 3 plus 3 equals, and again, that's a doubles fact, so we know that is 6. Okay? Not that bad. Let's go on to number 4. Let's do the same thing. Now, it doesn't matter what our shape is. I made circles. They're actually pairs over here, but this is stars. It's still an array. We have rows. We have columns. In the rows, we have 4 in each row. In each column, we have 2. Okay, so let's add up our rows. We have 4 plus 4. I don't know, 4 plus 4. And that equals 8. In our columns, we have 2 plus 2 plus 2 plus 2. And that, 2, 4, 6, 8, also equals 8. Okay? Now, I said before we started this is going to introduce us to multiplication. Here's how it does. Watch this. We have two columns of 3. Therefore, I know, and I'm just going to write it off this side here, 2 times 3 equals 6. But we also have 3 rows of 2. 3 times 2 also equals 6. So this is kind of prepping us for multiplication because the same thing is true over here. 2 rows of 4, or 2 times 4 equals 8. And 4 rows of 2, or 4 columns, 4 columns of 2, or 4 times 2 also equals 8. So arrays are repeated addition, and repeated addition is the same thing as multiplication. Okay? Instead of counting 3 2s, 2, 4, 6, I can just know 3 times 2 equals 6, or 2 times 3 equals 6. Okay? So this is kind of giving us an intro to multiplication. Now, the back side of this is talking about something a little bit different than what we've been doing. We have talked a lot about perimeter, meaning measuring the distance around something. So like this board that I have up here, this whiteboard, whew, that leaves some messes. We can measure the perimeter by measuring this side, this side, this side, and this side, and then that'll tell us the distance around it. But on the back side it says we're going to partition these rectangles. To partition them means we're going to cut them into pieces, meaning we're going to make cuts inside of them. So number 5 shows a rectangle that looks like this. Now, it says measure in inches. So you're going to need to get your ruler, and here's how you're going to do this with your ruler. You're going to take your ruler, your measuring tool, and then you're going to lay it out across there. So let's pretend this is my ruler. You're going to lay it across like this, and everywhere you have an inch, you're going to mark, there's an inch, there's an inch, there's an inch, and then you're going to take your ruler, and you're going to go just like this. You're going to go straight down. Now, if you really want to make it straight, you should probably measure inches along the bottom too. Once you're done, it should look something like this, number 5. However, did I measure mine? No, and you can tell. Does this look like this? Nope. So when you are finished, have somebody else take a look at it to make sure that all of your squares are 1 inch by 1 inch. Okay? Because that's what they should look like. Now down at the bottom of the page, notice what it says. It says you are going to measure in centimeters. So these are going to be smaller because you're going to use the centimeter side of your ruler. So top part, 5 and 6, you're going to use the inch side of your ruler. Bottom part, you're going to use the centimeter side of your ruler. But that's not all you're going to do. Then you're going to, down below, you're going to write down how many squares you find. Now, by how many squares, it means you're going to count 1, 2, 3, 4, 5, 6, 7, 8 are inside of each rectangle. And then you're going to write that answer here. And by the way, number 5 is going to have 8 squares, just make sure you measure them so that they're all the same size. Okay? So that's what you're going to do. You're going to count these up. Now, this is what we call area. When we find the outside edge of something like this, that's the perimeter. But when we find out what's going on inside, it's called the area. Now, if you were to go through our school, you would find a lot of places in our school where there are squares on the floor. The bathroom has little tiny tiles along the wall and on the floor. All those little squares, if we were to measure them all, we could count those squares. It would tell us the area of the floor. Right when you come into the school, we're coming from recess, there are slightly bigger squares. That long hallway that we have to walk down to get to the lunchroom and the lunchroom itself all have square tiles on the floor. You can count those, and each of those little squares, or big squares, they would tell us the area. And you could say how many squares are on the floor. So in your house, see if you can find some places that have squares that are marking them out. And if you measured those, then you would be able to figure out how many square units a place is. This is 8 square units big. And since we measured it in inches, we would write it actually like this: 8 inches. And you might see this on things, this little number 2 up here. And that means you've counted squares, 8 inches square, meaning that's the area of whatever it is that you measure. Now, if you look on paint cans, if you look on things like carpeting a room, when mom and dad talk about carpeting a room, they might say, we need so many square feet to cover this wall with paint, or, excuse me, to cover this floor. This is what they're talking about, covering the area of something, okay? So for this today, all I want you to do is measure your squares in inches, measure squares in centimeters, write down how many squares you find inside of there, okay? And that'll cover it for page 369 and 370. I am not giving you a second sheet, okay? There's no homework and review sheet this time, okay? Now, there is a second part of this, but I'm going to cut this video and I'll explain that on another video so this doesn't get super long, okay? All right, catch you in a bit.